sliding mode controller based P&O MPPT. Here we are using 250 watts panel. 250 watts panel. Here you can check the result of current voltage and power voltage for different. And then this is boost converter. And here we are using load. Here we are having PV measurement. Here we are measuring PV measurement. So that measurement, here we are going to measure the voltage and current of the PV panel. And it's going to be processed via P&O MPPT. This is P&O MPPT. This P&O MPPT will generate a reference voltage based upon the change in voltage and the change in power. Here you need to fix three parameters. That means before you have to fix the four parameter known as the initial voltage, maximum voltage, and voltage. This is the change in voltage. You have to fix this parameter, and then you have to fix the previous voltage, previous power, and the voltage. So here you are checking that V volt, P volt are G, and it has where you are now. Initially, does not have any value. That's why you are putting value for V volt, P volt equal to 0, and the V reference volt equal to initial volt. Here we are calculating the power, change in voltage, change in power. Based upon this change in power, first you have to check change in power less than 0. This condition true. Next you have to check change in voltage. So change in voltage less than 0, you have to decrement the voltage, or you have to increment the voltage. In order to get the math. If change in power is greater than 0, again you have to check change in voltage. If you are also you are going to check the change in voltage is less than 0. If it is less than 0, you have to increment the voltage or decrement. After decrement, just you have to compare the reference voltage in between, whether it is in between maximum minimum voltage. If it is not maximum minimum voltage, then you have to maintain reference voltage with the previous instant voltage. Every iteration you have to override the current voltage, power, and reference voltage with the previous voltage, power, and reference. You keep on executing in order to get the maximum. The output of V reference is going to be compared with the voltage, and then it's going to be processed via sliding mode control. So this is sliding mode controller. It receive two inputs. One is error, another one is rate of change output. This is guiding window for this sliding mode controller. It will provide some control signal. So that control signal is processed via hysteresis relay or hysteresis controller. It will generate the pulse for this IGBT to extract the maximum power from the PV. Now I am setting that the irradiation is the 1.8, 0.6, 0.4. It can be vary every 0.2 seconds. That means 1800, 600, 400. It will be very early 0.2 second. We will check the results. Here we can see the power, PV power, then load power. Here we can see the PV voltage on the load voltage. Here you can see that PV current and load current. I'm going to solve this model. This is PV power and this is boost converter output power. This is PV voltage and boost converter voltage. This PV current and boost converter current. This method is extracting power from the PV panel. These are the results of this previous method. Next we move on to the extension version. Instead of P&O MPPT, here you are using neural network MPPT. Here you are using neural network instead of MPPT. How that neural network is trained? Further you go to PV model. In this PV model, you have to provide the detail of solar panel we used, right? And then you have to generate the random temperature and the radiation, and then you have to collect the input data. Out here, input will be radiation temperature. Output is the maximum power from the PV panel. So once you have to simulate this one, you will see the result here. This input data is output data. Then you have to use the command and start, and then click shifting up, and then click next, and then select the input and select the output, and then click matrix source and click next, click next, click next, and then train the model. Here after training, here you can see that R value should be is 0.9, should be equal to 0.9 or should be equal to 1. Then our collected data or trained data will be or both are same. Next goes to click next, and then it comes here. Just you got to click Simulink diagram, and then you can use this neural network. This the developed neural network. This neural network can be used here. It can be received two inputs. One is radiation, another one is temperature. It will provide the reference voltage. I used the same thing only, same model as it is previous. Only we change this neural network algorithm concept like MPPT concept. Now here also same condition only we are using. Whatever thing we discussed in the previous method, same thing only we are doing. Here I am going to select the model. This is the result of extension version with the neural network. These are results. Here you can see that some changes in the voltage, but we are not see that difference in the previous method, but we can see the difference in the PV voltage because according to the change in elevation, the PV voltage will be changed. You can see that variation here. The PV voltage going to vary depends upon the irradiation temperature by using that. So sliding mode control based on neural network MPPT. This is a working of a previous and the extension version of the MPPT technique on solar basis. Thank you.